Okay, students. In your last video, we tried to find out equivalent resistance for series connection as well as parallel connection. Based on that, you must have solved the worksheet which was given to you. Now, we will move forward with the same topic, and here we will try to find out the equivalent resistance for the group of resistance where there is series as well as parallel combination together in a circuit. In last video or in the worksheet, you solved numericals where only series connection was there and only parallel connection was there. Now you will solve the numericals, or you will try to find out the equivalent resistance for the circuits where series and parallel combination is together. So let's move towards topic. So here is one circuit. This is my R1 resistance with value of 10 ohms. This is my second resistance and this is my third resistance. Okay, my second resistance value R2 is of 3 ohms and my third resistance, that is R3, is of value 7 ohms. Okay, now we will try to solve this part. We'll try to find out equivalent resistance for this combination of resistance. So I will move from left to right. Let's say when I move from left to right, my current I is flowing. So after coming to this point, this is the junction or the terminal where two resistance are joined together. So at this point, we will name it as A. There is R1 resistance and R2 resistance. So my current is going to get divided. Now you know your current is divided when there is parallel connection. So your R1 and R2 are in parallel. So from R1, my I1 amount of current will flow. So it will flow from R1 and it will come at the point B, that is a junction where two more resistance, that is one end of R1 and one end of R3 is joining at junction B, at terminal B. So here my I1 amount of current is coming through R1. Now we don't know what amount of current is coming from R3. So we will come back again at point A. From point A, I1 amount of current part we have done. So we will see to the next half part of the current, that is your I2 current. Your I2 current is flowing through R2 and it is coming out. So you got I2 current which passed through your R2 and here it is. Now the second end of resistance is connected with one end of your R3 resistance. So at this point where these two resistance are connected, at this terminal we will name it as C. So it is just like a U-turn on your road or a turn in your river where water is flowing and it will suddenly change its way. So my I2 current will flow from R2 and after coming at this point, that is at C terminal, it will take a turn and it will flow from R3 and it will come at point or at terminal B. So your I2 amount of current is coming at terminal B. So at terminal B, your I1 and I2 will get combined. They will recombine and I1 plus I2 will give you I amount of current. So now we are clear that at point A it is getting divided and at point B it is recombining. So there is parallel combination in between A and B terminal. So we will just draw the same circuit in a simplified manner and So at in between A and B, you got to know there is parallel connection, right? So this is your terminal A and here your terminal B. Same amount, I1 amount of current was flowing through R1 and there was nothing else in between. So your R1 is as it is. I2 current was flowing from R2 and R3. So R2 and R3 are in series because same amount of current is flowing from R2 and R3, that is I2. So this is your R2 and this is your R3. This is your R2 and this is your R3. Through R2 your I2 current is flowing, through R1 your I1 current is flowing. So you need to find out the value for this series, this resistance, that is R2 and R3, which are in series. So if you further simplify this, then your equivalent circuit will look like this. Instead of R2 and R3, you are going to keep one single resistance. So that is going to be in series. So we'll name that as RS. And this is your R1. So now this is your circuit, a bit simplified circuit or equivalent circuit where RS and R1 are in parallel. So then you will find out RT, which is in parallel. So in this way, one by one, you are going to find out. These are going to be the steps through which you will find out your total resistance. So let's solve it one by one, step by step, and let's get the value of your RT, that is your final resistance provided by the combination of these three resistance. So in step 1, what you are supposed to do? You are supposed to find out the value of R2 and R3. R2 and R3 are in series with each other. So for series, RS equals to R2 plus R3. Value of R2 is 3 ohms. 3 plus 7, that is equals to 10 ohms. So here you got the value for your RS. Your RS is 10 ohms. The value for R1 is also 10 ohms. Now your RS and R1 are in parallel. So you will find out value for this. So finally you will get one single resistance or the value that is going to be a final value. So for parallel connection, 1 upon RT equals to 1 upon RS plus 1 upon R1. That is equals to 1 by 10 plus 1 by 10, which is equals to 2 by 10, and that is equals to 1 by 5. So your RT is equals to 5 ohms. So the value for RT, you got it as 5 ohms. So if you take a single resistance of value 5 ohms, then you can replace this 3 resistance with a single resistance of 5 ohm, and the same amount of current will flow from that 5 ohm resistance.